Good morning, everyone. Welcome to this webinar about the new European Carbon Adjustment Mechanism. With me today, we have very interesting speakers. I'm quite happy to present you. For this 1 hour and a half, we will talk about this new system about the importations for the European Union and the carbon price that will be fixed on these new importations. So today we will have a very quick introduction. I will present to you like ABC, what we do, what we want to do in the future. Then we will give the floor to Houssem, Matthieu, and Anna to talk about the CBAM and how it will impact European and global economy. And then we will have a quarter, 15 minutes, I would say, to answer your questions. Please feel free to write in the chat what you would like to ask to our speakers. So very shortly, ABC, we are an NGO. We are working on carbon accounting methodologies and tools. We have been created in 2011, so it's been more than 10 years that we work in France and in the Europe in general to improve carbon accounting, to develop sectoral methodologies, sectoral tools, to help companies, but also local authorities and individuals, and also in students to assess their emissions and try to find ways to reduce them. We are starting today new programs about adaptation. We are, of course, integrated into French, I would say, policies about climate, and we provide the help and new tools for all the stakeholders that would like to act on the climate transition. We have four main goals. We want to provide appropriate tools and methods. We want to bring together the expertise and stakeholders. We want to become a reference, maybe not the leading, but at least a reference resource center dedicated to the low carbon transition. And of course, we want to act at the international level. So we want to expand from France, from the West Europe, I would say, and to provide our help and our methodologies to everybody around the globe. So with me today, we have Houssem Belhouam, who is head of IMPACTE Unit in CITEPA. Houssem, can you present yourself, please?
Yeah, thank you very much, Quentin. It is a pleasure for me today to be with you for this webinar. My name is Houssem Belhouam. I'm head of IMPACTE Unit. IMPACTE, it is an abbreviation to say that we work on instrument and market and carbon markets, and as well as GHG mitigation policies, as well as energy transition. And it is the main topics of my intervention in CITEPA. Thank you very much.
Thank you, Houssem. With us also, we have Anna Kriti, who is Scientific Director of the Chair Climate Economics Professor at Paris Dauphine University, but also a lot of other things as well. Anna, can you introduce yourself, please?
Yes, thank you, Quentin. Good morning, everybody. It's a pleasure to be here for many reasons. One is the most important in this context is that beside my role as a professor of economics and head of the Climate Economic Chair, I'm also the president of the ABC. And the second reason is that because our first meeting with the ABC was on this same topic. So I'm glad to expand what are our thoughts in terms of the, let's say, the what the literature in economics has been thinking about this CBAM. I have to say that my American colleagues and especially those who are not concerned directly by the CBAM are a little bit jealous because we have motives to continue doing research on carbon pricing, and this is what I'm going to explain later on today.
Thank you, Anna. And Matthieu, you are International Development Director for NEPSEN. Can you introduce yourself, please?
Sure. Thank you, Quentin. Thank you for ABC organizing this webinar. So my name is Matthieu Claus. I'm head of international development at NEPSEN. NEPSEN being an entity specialized in energy and carbon transition, both in France and abroad. And I'm working on carbon and energy since almost the beginning of carbon footprint in France. Thank you, Quentin.
Thank you, Matthieu. So without further ado, I think I will let Houssem take the floor to talk a little bit about the CBAM, what it is, what we can know about it already, and the key takeaways to have all our viewers on the same level of information.
Yeah, thank you. Yes. Thank you, Quentin. Yes, in our presentation, this presentation will try to see together the key takeaways of CBAM and its main features. As you know, we cannot all present in 20 minutes, but we'll try to explore the main features, at least for the transitional period. What is CBAM? So, returning to the basic, CBAM, it is the abbreviation of Carbon Border Adjustment Mechanism. So, as you can understand, there is an adjustment to be done at the borders of the EU. It is implemented by European Union as part of its Fit for 55 package, and this Fit for 55 package was introduced as legislative reforms by EU to achieve its 2030 climate targets of reduced net GHG emission by 55%. That is why this package was entitled Fit for 55. And CBAM, it is a main instrument because it completes the other main instrument of European climate policy, which is the EU ETS, so the European Emission Trading Scheme. And as we will see together, CBAM will try to replace all carbon leakage instruments which are related to the ETS. Just to keep in mind that CBAM entered into application in its transitional phase since 1st October 2023, and since that date, all importers for the CBAM covered goods must follow all the imported goods and must make their first CBAM reports in 31 January 2024. That is 2 weeks ago. So what is carbon leakage? CBAM, it is an instrument against carbon leakage, but what is carbon leakage? Carbon leakage is relocation of carbon-intensive production, European ones, to third countries for reason of costs related to EU climate policy. And here we are talking about carbon costs because in the EU ETS, operators must purchase allowances, and that allowances correspond to their verified emissions. So there is a carbon price to be paid by the operators. So the idea here is to fight against this carbon leakage and relocation. That is the first form and type of carbon leakage. The second one is when EU products are replaced through imports of more intensive, carbon-intensive imports, because in other countries they don't have carbon price, so the production cost plus zero carbon price make that products less expensive, and then there's a risk of replacing EU products which are more expensive because of carbon pricing. So CBAM will initially apply to not all sectors covered by the ETS, but to the most sectors that are at risk of carbon leakage and at the same time are carbon intensive. So it will apply to 7 sectors: iron and steel, aluminium, fertilizer, electricity, and hydrogen. And it is not applied only to sector, but also to certain goods and selected precursors that are pertaining to these sectors. And we will see after that some definition related about what are simple goods, complex goods, what are the definition of precursor. All that we will see it together after that. So CBAM, let's keep in mind, it is designed to function in parallel and to complete the EU ETS. It aims to gradually replace all existing carbon leakage measures, particularly the allocation of free emission allowances in the ETS, because not allowances are purchased. There is some part of allowances which are allocated for free. So the idea here is to put a carbon price on the products imports out and product imports in the border of the EU, and to have the same carbon price, as you can see in the figure below at right, in the same way that producer in third countries will now pay a carbon price, while producer in the ETS are paying for their ETS allowances. Because in the initial situation, as you can see in the figure, in the figure, you can see that production in the ETS, there are some ETS allowances that must be purchased by operators, while for other countries there is no carbon pricing, and here the production cost may be less expensive for these third countries than those in the EU. So the idea is to put this carbon pricing in the definitive phase, because now we are in the transitional phase. There is no carbon pricing now. There is just reporting requirements. Next, please. So the timeline, we have two phases for CBAM implementation. The first one has begun in October 2023, and it will end in December 2025. This phase is focused on monitoring and reporting only, but however, even if there is no financial adjustment, no need to purchase certificates, there is penalties for non-reporting or for misreporting. Here, importer of CBAM goods must every quarter submit their CBAM report, must appoint customer representative if they don't have customer representatives, or if they intervene as direct importer. So there's no problem here. They can themselves undertake the report submission of CBAM. So the idea here is that every 3 months, the importer of CBAM goods must submit a quarterly CBAM report outlining the embedded emission associated with goods imported. And here there is a new concept of emissions. We are talking not about direct and indirect, we are talking about embedded, and we will try to find some definition and explore the definition of this term in the next slides. So here importers have to report 3 main items: embedded emissions of quantity of good imported, and as well as any carbon pricing due in third countries. Starting from 1st January 2025, these importers, however, must now become an authorized CBAM declarant, so they must submit a declaration form for the competent authority to be authorized to intervene as CBAM declarant. For the moment, there is no specific form for declaration for the first year, I mean for 2024 year. What is important also to keep in mind is that in 2025, the EU, the European Commission, will make some proposal about the review of the CBAM scope to include other goods and sector of the EU ETS. So the initial scope could be extended to other sectors, but sectors always covered by the EU ETS. The definitive period starts at 2026 and will end at 2034. Here, only authorized CBAM declarants will be able to import CBAM goods into the EU. No authorization, no import. It is prohibited. Authorized CBAM declarants will have to buy CBAM certificate, and the price of that certificate will be coupled with the EU ETS allowances. So we will have nearly the same price of carbon. And here the CBAM certificate, their quantity will correspond to the embedded emissions in the imported goods. Also, what is interesting to know here, that to ensure coherence with ETS, the CBAM certificates are phased in gradually in line with phase out of free allowances in the EU ETS. And we'll have a figure in the next slide, that will explain this mechanism. So just to have an overview of reporting responsibility in the transitional period, as you can see, the main role is for the importer, which is the reporting declarant. The first step is to import goods from third countries, and the importer could have a relation with many suppliers. So in this case, the importer must request data from all these suppliers about the imported good. After that, the importer must undertake the customs process and obtain the custom release. The custom authority will inform the European Commission through the CBAM transitional registry about the import of goods by this importer. The fourth step is to request data on embodied emissions, and after that, because here we don't have already submitted the CBAM report, and once we have requested data on embedded emissions, here the importer must submit every 3 months its quarterly report on embedded emissions, take into account this data provided by the supplier on embedded emissions. And once the reports have been submitted through the CBAM transitional registry, there is information exchange between competent authority of member states where the importer has imported its product. And here, if the importer has not submitted its report or has misreported, there is a risk of penalty for this importer. Next, please. I will not present all these elements, but just to have in mind what types of information must be reported in the quarterly report of CBAM. Main information is the quantity of goods imported and the type of goods as identified by their combined nomenclature code, country of origin of the imported goods, installation where the goods were produced, production routes, specific parameters like, for example, clinker rate for cement, specific embedded direct emissions of the good, electricity consumption to calculate the indirect emission. And here we are talking about production process, not all the installation. For electricity, we have to precise if it is actual emissions or default value based on default factor emission factor, corresponding emission factor of the electricity consumed, specific embedded and direct emissions, and last, carbon price due in a country of origin for the embedded emissions. So, just to have also in mind that there is penalties for non-compliance, and non-compliance means two things. The first case, don't submit the report at time. Here it is the first case. The second case, information are misreported, or we don't have actual data about installation data for the third CBAM report. Here there is a risk of penalty of about between 10 and 50 euro per ton CO2 equivalent of embedded emission. So as you can see here, there is a risk of financial charge for reporters if there is some risk with reporting. You have in the table some dates about the date where the report must be submitted. And now, what's about the sector and goods covered by CBAM? We have 6 families, and here the idea is to present you some basic concepts about the combined nomenclature goods and aggregated goods category. In each sector, we have CN goods that are listed in this sector, and these CN goods sometimes are aggregated under goods categories. So EU CBAM goods are, as I said, identified by their combined nomenclature code that you can, for example, find in box 33 of your custom declaration in EU. Goods are also grouped based on their similar characteristics in aggregated goods category. And just to give you some example, in the cement sector, we have 6 goods, and we have 4 aggregated goods categories that you can find in the table below. As you can see, and you have here on the left side 6 goods, and on the right side we have 4 aggregated goods category. So in CBAM, the idea for monitoring, you will see that after, is to be based on aggregated goods category for monitoring data emissions. Next, please. What are CBAM's simple and complex good? It is other concept of CBAM here, but just to have some elements in mind. Simple goods are produced from input material that have zero embedded emission, while complex goods are based on it is necessary to include the embedded emission of relevant precursor used in the production process. So for the upper figure, as you can see, for all this pink block, there are material with no embedded emission because there are fuels that will go for combustion, or are raw materials that were not processed in the plant. Here we have limestone for this example for clinker. We have alternative raw materials. We have fuels, alternative fuels. All these materials are raw materials, so there is no embedded emission according to CBAM definition. However, the clinker is a simple good because we don't have other input material with embedded emission that entered in the production process. Here, for the cement that is produced based on clinker, we have clinker as input material, but clinker here has embedded emission. Also, calcined clays, if used, have embedded emissions, and in this case, cement is considered as complex good. So the idea here is to present you that in CBAM we have 2 types of goods. We have simple and complex good, and that depends on the embedded emission of precursors that are used in the production process. And here the clinker is considered as precursor. Precursor, it is input material that is itself CBAM good, but it is used in the same time in the production of complex CBAM goods. Next, please. So, what is the emission coverage in CBAM? Generally, the emission coverage in CBAM corresponds and reflects the emission causing CO2 costs in the EU ETS. We have here 3 blocks. The first block is direct emission of EU ETS installation. So here, as you know, carbon price in terms of allowances are paid by operators of own direct emission related to their combustion and process emission. The second cost borne by EU operator is the indirect emission through CO2 price included in purchased electricity that is produced from another EU ETS installation. Here, the operator will borne the cost of this purchased electricity, so indirectly the carbon price. And the third block is related to precursor emissions. For example, the clinker is processed and produced in another EU ETS installation. So if it is used in cement production, here there is indirect cost of precursor emission. So the idea of CBAM is to reflect all these carbon costs in the EU ETS. So we have 3 types of emission. We have direct emission of goods, we have indirect emission of goods, and we have precursor emissions that enter in the production of complex goods. Next, please. So just if you want to have an idea of the value chains and what are the sectors or steps included in the CBAM boundary, as you can see in the figure, all no embedded emissions related to raw materials, because raw materials don't have embedded emission in terms of direct emissions, here are not included under CBAM, even if this raw material was processed in refining units, was extracted. But here in CBAM, we don't consider all these emissions related to downstream, to upstream steps. In CBAM, we consider 3 types: the direct emission at installation unit, the second one are indirect emission related to purchased electricity, and the third one are precursor emissions that enter in the production of complex goods. And the idea is also to split the installation in CBAM goods and other goods. Other goods which are produced in the installation that are not covered by CBAM, their emission will not be considered. We will just consider the emission related to product under CBAM scope. So there is a step where there is attribution of emission by production process under CBAM monitoring. Next, please. So just shortly, there is many steps to determine actual specific emission, embedded emission of good. The idea is to begin, it is a top-down approach to begin from monitoring at installation level during the reporting period, monitoring all data emissions, flows of net measurable heat, electricity consumption, consumption of precursor. After that, we will determine the emission of the installation. So once the emission at the installation level are determined, the idea is to split the installation into production processes. And here we will, in the next step, attribute direct emission and indirect emission by production process. And once we have attributed emission to these production processes that generate CBAM goods, we will add possible precursor emissions. And after that, once we have added precursor emissions, here, direct and indirect, we'll have the embedded emission of the goods produced. And to go and to achieve, to arrive to specific, we have to divide that by the activity level. So the quantity of CBAM goods produced by this production process. So it is a top-down approach for determining specific embedded emission. Next, please. Just to give you what are the monitoring methodologies allowed by the European Commission for calculation of embedded emission. The first method and the basic method is the EU method based on calculation-based approach. Here we have two forms. We have standard method based on activity and measurement of activity data and laboratory analysis of carbon content or standard value if we don't undertake such analysis. The second method is mass balance method, where we try to measure the carbon entering and the carbon leaving. So they are applied to source stream, like in the UTS. The second type are measurement-based approach. It is applied mainly for nitrous oxide emission from nitric acid production and CO2 if it results in more accurate emission estimates. It is applied in this time at emission sources in stacks, or it is parties of the installation. So what is important to know here is that EU allows other methods until 31 December 2024. It is non-EU country specific method if, and here it is a very strong condition, if they lead to a similar emission coverage and accuracy. So these methods are related to carbon pricing scheme, compulsory emission monitoring scheme, emission monitoring scheme with verification. There is also, until 30 June 2024, another method that are allowed. So the default reference values of embedded emission that were published recently by the European Commission. So if the supplier don't have the data, it can in this case use the default value, but until 30 June 2024. Starting from 1st January 2025, only EU method is accepted, but there is also some acceptability of estimates to be used if the estimates are less than 20% of total embedded emission of complex goods. But starting from 1st January, there is EU method only acceptable in general. And just to give you an idea of the concept of monitoring of direct emission on installation level, it is monitoring of all source stream. Here in this example, we have to monitor the natural gas stream, so quantity through a meter. The same for fuel oil. Also for raw material, we have also to meter the quantity as well as for coal. And as you can see here, we have production process that is related to rotary kiln, but also we have exchange of stream of heat between other production processes. So the idea here is to undertake monitoring of all these parameters through measurement and done by meters. And just to have in mind for importers, an important item is that for the CBAM report, due in the first quarter of the year, the data of the previous year should be used. So this means that operators in third countries must undertake monitoring of all these parameters for the previous year and calculate embedded emission based on the data of the previous year. Next, please. Here, just to give you an idea about the definitive period, how it will function from carbon pricing point of view. As you can see on the upper part of the figure, we have CBAM, and the down you have EUTS. So here the operator in CBAM in third country will have to pay CBAM carbon price based on the purchase of CBAM certificate. And here, as you can see, the idea is to go in parallel and to apply this carbon pricing in parallel with EUTS in parallel. So the EU producer will just purchase 2.5% of each emission through allowances, while for CBAM good, the importer will pay for 2.5% of embedded emission. Gradually, this part of carbon pricing of emissions will increase. So we'll go in 2030 to a part of 55.5%, while attaining and achieving in 2034 100% of emissions that are subject of carbon pricing. And it is the same in the EUTS, where 0% of free allocation are applied in that horizon, and 100% of emission must be covered by allowances purchased by the EU operator. So the idea is to function in parallel. Now, some challenges for this coming period and for the definitive period. The first one is for importer not obtaining timely or complete data of goods imported to enable compliant CBAM reporting. That could result in penalties for the importers, and penalties are very high, as we saw in the previous slide. The second challenge, in my point of view, would be developing monitoring methodology and installation level by operators in third country. It is innovative monitoring challenges for me, because such monitoring methodologies are applied since 10 years or more than 10 years in EU, in the UTS, and now just transposing the same monitoring scheme will be a challenge for developing countries. Another challenge will be performing monitoring of emission at installation level. I think here there is need to go for measurement, measurement of quantity, measurement of carbon content of materials as well as fuels. So here there is challenges about who will undertake this measurement, which laboratory, and what's about the accuracy of this measurement. So many challenges related to monitoring of direct emission, including heat and direct emission based on electricity consumed, purchases, precursors, etc., etc. Another technical challenge is the attribution of installation emission to production process of CBAM goods. How it can another challenge in the third-party verification of emission report, which is mandatory. Who will bear this cost of verification and how to undertake this verification? Another challenge is to decarbonize production process in third countries to pay less carbon adjustment while aligning with EUTS product benchmark. And there is also cost consideration. Who will be the CBAM carbon cost? It is additional cost for importer, but importer could minimize this cost by choosing supplier with less specific embedded emission, or would pass on CBAM cost to supplier, and here the supplier will bear the cost. Other challenges are related to ability of third countries to implement carbon pricing schemes like carbon tax UTS with a price that is close to that of UTS. As you know, now we are about 70 euro per ton. Is it possible for third country to apply carbon price with 70 euro per ton for their emissions? So that is some challenges. That's all from my side. Thank you for your attention. And just you can reach out with me through this email address, as well as with CITEPA through our website. Thank you very much.
Thank you so much, Houssem, for all this information in the short time that we could give you today. So thank you very much. After all that, I think we ask ourselves, we have to ask ourselves as ABC, is Bilan Carbon useful to answer to the all, maybe not all, but some of these challenges that Houssem just told us about. Matthieu, I give you the floor to talk to us about like the carbon accounting point of view for the CBAM.
Well, thank you, Quentin. So now I propose to study, to guide you, how we can move from these text definitions, those referentials, to try to assess what amount of greenhouse gases emission would be subject to CBAM and how to quantify it. First, so we've got a lot of greenhouse gases assessment methodologies with a lot of referentials. Which greenhouse gases are we going to consider? I propose a distinction of 3 categories of greenhouse gases. First one in green, when you've got carbon dioxide, nitrous oxides, and perfluorocarbons. That are the only gases that are subject to be considered by CBAM so far. Carbon dioxide for any installation, any product that will be subject to CBAM. Nitrous oxide only for nitrogen fertilizers, and PFCs only for aluminium product. So first we are going to consider only those 3 gases or family of gases. At the difference when you include the gray gases, methane, SF6, HFCs, and NF3, which are the Kyoto Protocol and now UNCCC protocol. And when you add the purple gases, HCFC, CFCs, which are chlorinated, water vapor from the planes and so on, you've got the total greenhouse gases emissions from humankind. So to put it in a nutshell, in green, you've got the gases that are considered by CBAM. When you add the gray, you've got the Kyoto Protocol gases, and the total are the gases that are considered by Bilan Carbon methodology, considering any gas from human activities that has an impact on global warming. No, sorry, Quentin. Now regarding the scope boundaries, the EU ETS was quite simple. It comes from the target activities and then scoping at some sites. And at the scale of the sites, we were considering the direct emissions that were related to the process. So it directly fits with a special scope of ISO 1464 for scope 1, but focusing on process-related emissions. Now, regarding the CBAM, we are going to look at direct and electricity emissions of target products by CBAM. And we'll see in the slide just after that direct emissions of target products are part of them on site and part of them out of your site, included in your precursor, including in your raw materials. So these CBAM definitions does not fit to ISO 1464, ISO 1464 scope 1, neither scope 2, but it's wider than that. And of course, it fits in direct and indirect emissions of Bilan Carbon global scope. So next slide. So we have to precise what we call scope. regarding Bilan Carbon on CBAM. And here we have a real trap because both Bilan Carbon and CBAM have direct and indirect emissions. In Bilan Carbon, we are used to speak of three scopes of emissions. Briefly, direct emissions, that are the emissions from the control operations. The indirect emissions from consumed energy, taking into account both electricity and heat networks. And you've got the other indirect emissions, taking into account raw materials, packaging, services, and so on. The aim of carbon footprint being to do a mapping of greenhouse gases emissions so as to prepare an action plan for reducing our internal or indirect greenhouse gases emission. Now, regarding the CBAM, you've got a two-square scope of emission. You've got direct emissions, which are the emissions related to the process of CBAM goods production. These direct emissions, the parts that you've got on site, that's your attributed direct emissions. These are the direct emissions that you've got on site, plus the emissions due to your heat consumption for the process that you import, minus your emission of heat production that you export, plus some corrections of waste gas, minus what you export, and minus your emissions that are related to your on-site electricity production that you may export. So it's a first difference. You've got some plus, some minus in your direct attributed emissions. And when we go to indirect emissions, here it's only related to electricity. So it's a major difference. Indirect in the sense of ISO 1464, it's electricity and heat, so any form of energy. Here, indirect in the sense of CBAM, it's only related to electricity. And now you include as well the precursors, as Houssem from CITEPA said in the previous presentation. Precursors are your raw materials that you consume that are scoped within the CBAM exercise. And for your precursors, for those raw materials, you're gonna include as well the direct and indirect emissions. So at the end of the day, you assess some specific embedded emissions at both direct and indirect scope that consider your on-site emissions plus the direct and indirect emissions of your raw materials that you purchase on consume on site. So we can switch to next slides. Thank you. Those are the three possibilities to assess those greenhouse gases emissions. First, we have to use some direct measurement. It's a recommended approach for direct emissions that you have on site. And it's recommended as well for the direct emission from your raw materials that comes from your other producers. So it means that you will have to ask to the ones that produces your raw material you consume, what are the specific embedded emissions related to the product you purchase. Other possibility is to use emission factor with your consumption. For examples, direct emissions of fossil fuels or fossil resources that you can use as product with partial oxidation and so on. Still, it's at the scale of the process. it means that your boiler to hot the water is not part of the process. Indirect emission of energy for process purpose on your precursors. Third possibility, as Houssem said, you can use default values of embedded emissions without restriction until end of June, and with limited contribution to 20% of your specific embedded emissions from July 2024. So I propose to use a case study so as to try to identify what are the specificity on how we can conduct the CBAM emission assessment. So in this example, so it's typical plated steel. It's a pure fiction. It's not a real industry. We are going to do a Bilan Carbon and a CBAM specific embedded emissions assessment. This industry is a secondary route metallurgy, and it produces some plated steel with zinc. First thing to do is to look at the custom nomenclature, so the custom codes, and to look at this product, if it's scoped or not by CBAM. In our case, so we product some flat roll products of some alloy steel with a width and plated with zinc, and we fall directly within a category which is scoped by CBAM. So the first thing to do. Second is to look at the methodology that is proposed under the European Commission resource website. And then to look at energy on raw materials. In our case, we use natural gas and electricity for the process, and we'll see afterwards that we'll make a distinction between the process and other uses. And regarding the raw materials we use, so we use some iron scrap, which is a recycling activity. We use some ferrous alloys. And then we look more in details regarding the custom code, if they are scoped or not by CBAM. We use HBI, we use zinc. And for each raw materials, we have to screen if they fall under CBAM scope or not. Our clients, part of the clients are in European Union, part of our clients are outside EU. And even for the clients outside EU, some of them are producing some pylons, for example, with again another custom code, and the pylons are falling within CBAM scope. So it means that I can have clients that are only located outside EU. Still, they will ask me to produce some CBAM information to do their reporting. So it's very interesting because we see that similar to Bilan Carbon, we consider in the scope our raw materials, and our client may ask us information regarding our internal greenhouse gases emissions, even if I am not directly impacted by CBAM. So, as I said previously, we look at the European Commission methodology. In this case, so it's an electric furnace using scrap. So similar to the third column, here it's the example of an electric arc furnace. Still, it's very similar with induction furnace. And I look at what has to be considered. And here I clearly see, with the different method, that steel scrap is not a CBAM product, and we'll see afterward what are the embedded emissions to consider. But HBI or RBI, DRI, sorry, so reduced iron has to be included in my CBAM assessment. So it means that this consumption of raw materials will have to be assessed in terms of direct and indirect emissions. So we can go to the next slide. A small comparison of emission factors and specific embedded emissions default value. So these specific embedded emissions default value are the values that I can use if the producer doesn't give me any relevant information regarding the materials I purchase. And we can compare with the base carbon or with bilan produit on different kind of materials. It's quite interesting here because we see that we've got some significant details within CBAM specific embedded emissions default values. This with a distinction of direct and indirect emissions. And again, it's a trap. Direct means that the emissions that took place on site of production, and indirect is electricity. We can see that in the CBAM is directly related to the CN code, to the custom code. And the custom code does not include a mention of the percentage of recycling, and does not include any mention of country where it was produced. And we know that some materials using a lot of electricity are using a different portion of recycling component, that we've got a significant dependence on the country, on the percentage of recycling content. So we can go to the next slide. Here is a comparison of the global Bilan Carbon landscape, greenhouse gases signature, on the CBAM. To put it shortly, so we've got the first differences on energy. We have to make the distinction of energy for process, which are my two first columns, and energy for other uses. For example, for buildings, for producing hot water, and so on, which will be out of CBAM scope. So here we consider only in the first column the energy for process. And then in the energy for process, we look only at direct emission of the fuels I'm going to burn. It means that upstream part of fuels, extraction, refining, transport is out of CBAM scope. And similar for electricity, it's the indirect emissions. So it means that the emissions that are at the power plant of electricity. So it means that transport and distribution loss are out of CBAM scope. On upstream emissions of the fuels to produce electricity are out of CBAM scope, even if taken into account into a global Bilan Carbon assessment. I could have some potential direct emissions of carbon oxidation on site, which was not the case in here. Then regarding the raw materials, in my case, I only consider the metals that I consume as raw materials, meaning that the chemicals or other materials will be out of CBAM scope. And regarding the services I purchase, the packaging, the freight, the people transportation, my wastewater, and my capital assets, it's definitely out of CBAM scope. So here we clearly understand that with the raw materials consideration for a manufacturing activity, it's one of the most time-consuming item of Bilan Carbon assessment. But I've got a frustration when performing only a CBAM assessment, because I've done more than 50% of the data collection to assess the greenhouse gases emissions, but I'm still a little blind by this disability of seeing the global greenhouse gases landscape. So with this greenhouse gases assessment, then I can do the compilation and calculate the specific embedded emissions for this case study. And I will do the distinctions of direct and indirect emissions related to my CBAM good, which is steel alloy, thin plated. Direct, again, so of course it's direct emissions of my fuels combustion on site, but it includes as well the direct emissions of the raw materials that are scoped by CBAM. So here, in my direct emissions for my product, I will consider as well the ferrous alloys I consume and the reduced DRI, the reduced iron I consume. In my indirect, I've got my electricity consumption plus the electricity consumption for the production of the raw materials I consume. In this case, we identify some ferrous alloys. We've got a precision on the European Commission regarding the scrap. So when I consume scrap, so it's post-consumer scrap, meaning recycling activities, it has 0 embedded emissions. And here we can see the total of the column is the default values of specific embedded emissions on both direct and indirect. And I'm something like 40% below these default values, because in this case study, consuming a lot of scrap without embedded emissions in this CBAM methodology. Now, question is, well, what's at stake regarding how much it will cost? On the question afterward will be who will pay. So again, the Bilan Carbon enables me to assess this related cost of CBAM at EU border. First, on the left side of this slide, I consider the specific embedded emissions. For now, we know that regarding cement and fertilizers product, both direct and indirect emissions will be impacted by CBAM. Regarding iron and steel products, we don't know. So far, it's envisaged that only direct emissions will be subject to CBAM adjustment at the border. So I will do 2 simulations, one with direct emissions, the other with direct and indirect emissions. Then how far am I going to look? So I propose to look at 2030. So around 50% of my CBAM emission will be subject to financial adjustment. Unto 2035, when 100% of my emissions will be subject to financial adjustment at the border, of course, for the portion of products that enter EU. Finally, how much it will cost. So against the tool Eco-Entreprise of Bilan Carbon enables us to do some different simulations. I made one with 80 euros per ton of carbon dioxide, and the other at 120 euros per ton of carbon dioxide with this tool of Bilan Carbon. On the next slide, you've got the result. So on the left, it's a chart of the price of similar kind of steel that I produce from 2020 to yesterday. So it means that it's covered almost 5 years of period. And what I'm looking at is in 5 years and in 10 years. So we understand quite quickly that what at stake, what will be the price of such a product in 5 years and in 10 years, it's quite impossible to predict. So in 5 years, what at stake, the additional cost of due to CBAM adjustment at EU border would be between 50 euros and 100 euros per ton of carbon dioxide, and it's the orange on the red that you have in the chart. And in 2035, what's at stake, it's between 100 and 200 euros per ton of product regarding to the CBAM adjustment at the border. So we understand quite quickly that even if it may represent a significant amount of money regarding the tonnage I produce, it won't change radically the way of production, but perhaps just to reorient to less emitting countries because of this CBAM inclusion in the carbon price. When we go to the next slide, so in conclusion, initially the EU ETS was focusing on direct emissions of electrical plants, cement plants, iron plants, and so on. To replicate this scope of emissions at product scales, the CBAM has to consider direct and electricity emissions of cements, irons, and so on goods, including precursors emissions for their direct and electricity emissions of scoped plan. As a consequence, the CBAM specific embedded emissions, when we assess it, we have to include electricity, meaning ISO 1464 scope 2, and raw materials screening to include the raw materials that falls under CBAM categories, meaning ISO scope 3. The specific embedded emissions default values that can still be used after July 2024 with a maximum of 20% of my embedded emissions. They are defined in correspondence of CN code, and those CN code are not country specific, and they are not modulated in regards of recycled content. It may result that I've got overestimations of my specific embedded emissions using these default values. So it worth it from a few hundreds of tons of EMAS CBAM goods entering in EU to fine-tune my embedded emissions of precursors, even if still enabled below 20% of my total embedded emissions. On the final aspects, as the raw materials consideration in a Bilan Carbon for manufacturing activities, it's the most time-consuming item. So doing a global CBAM assessment, it's a real opportunity to look wider, to remove those blinds and to do a global greenhouse gases assessment, for example, using Bilan Carbon methodology. Well, Quentin, I hope I'm on time.
You're on time. You're on time. Thank you. Thank you so much, Matthieu. It's always like very easier when you have a good example to show. And I really appreciate what you did about Bilan Carbon and explaining that maybe CBAM was maybe oversimplifying things, and we could like take the opportunity from CBAM to do like a proper carbon assessment. So it's very good. And thank you for all this information. Now I propose to like focus on a more research point of view, and I give you the floor now to present your vision of the CBAM and maybe the problematics that are occurring with it.
Thank you very much, Quentin. Thank you also to the two previous speakers. I really admire what is going on, and we see from the previous talks that the devil is really in the detail for this kind of new climate policy. But I'm taking some complementary perspective. So I take a step back and I'll try to summarize here, which are the quite recent debates all along the development of the CBAM. I'm trying to refer to the main results that we can have, knowing that, of course, when we'll go into some quantitative results that I'm going to show, those results are being simulated on the basis of specific models. And I'm going also to detail which are the assumptions that are taken and which are I think the most important aspect, that is the drivers of the effect that I'm going to illustrate. Just setting the scheme, because we have gone so far a lot in the details, but which is the main point of this carbon border adjustment? In the economic, but also in the legal literature, so about economics and law, I would say, the first bunch of models have tried to assess which kind of design of the CBAM would be online with the Article 6 of the World Trade Organization. So the first issue has been really to understand whether imposing such an adjustment was going to hinder the main point, which is the free movement of goods across the world. So responding to actual and potential critiques, the CBAM has taken that into account, and the version that we have now is robust to this potential critique. This is a point that we have also to underline, because you may also think that with all these difficulties that have been underlined so far, we are somehow escaping some international legislation. So as far as we know, no. I mean, this has covered a lot of debates at the European Commission that has come out to something that is robust to the global problem of trade organization. The second point is the one that is displayed here. What we want to achieve. We want to leverage all the carbon prices that exist in the world and that doesn't exist. So, and here in this slide, we look at exactly this divide. So we have a bunch of countries that doesn't have explicit or implicit carbon pricing. So which is the difference? The difference is that in some countries, what we have is a tax. In other countries, we have system of quotas. In other countries, we have indirect legislations that are going to still tackle the problem of CO2 content in several sectors. Another difference between when we assess this carbon pricing is the perimeter that encompasses the carbon pricing, which varies a lot according to the different countries. So for the perimeter, I intend whether it covers only the combustion sector, to use what it is the term in the EU ETS, that is mostly energy, or also other sectors. So here we display this ranking of average carbon prices in 2020, just to, fix an initial point, and to see that even within the European states, accounting for additional taxes, CO2 taxes, we see that Sweden is the one that ranks first among the European countries, followed by non-European countries, that is Iceland, Norway, and then we go back to Europe, Finland, France, with our compensation Climat that is freezed so far. I'm waiting for maybe further revisions. But still we have a bunch of countries and we are going to think about and to have comments about them that are outside Europe and that have very little or no carbon pricing, even though the carbon pricing strategy is evolving and touching more and more what we call the global south. But still, among those countries that doesn't have at least an explicit carbon pricing, so we found some trading partners of the EU, and this will be a fundamental point that we're going to see later. So now switching to the next slide, what we can say. If we look, this was just a snapshot in 2020, but of course, it's in particular, if we look at what is going on in trading carbon, we see that if we have to compare what is going on in the US, because this is the anchoring point of the CBAM, that is the price that we have in the EU, and the comparison with the trading partners, we see that the first trading partner we will be concerned with is, of course, the UK after the Brexit, but still our economies remain quite linked. And we see that there is a substantial similarity of the UK ETS and the EU ETS. They diverge lately, and this is due to the contingency of the energy crisis that has triggered more, let's say, change in the UK than globally in the US. This is mainly due to the functioning of coal generation units in the UK. But if we go to something that has attracted also the attention in the economic literature, that is, everybody thinks that the first country that will be affected by the CBAM is China, which is actually not the case, as we're going to see later on. So even in a country like China, that is, of course, an important trading partner for the EU, has a carbon price, but the level of this carbon price is very low and relatively stable. So it approaches more or less tax. And also the perimeter of the Chinese ETS is very different from what we have in Europe. The common point is electricity. And now, just to give you an idea for what we are going to, again, analyze later on, we now also start understanding why electricity is part of the sector targeted by the CBAM. So going further in the slides, so next. So as I was saying, there are many papers that look at the CBAM, and it has started more or less 15 years ago, when this idea was already in the pipe. And here I refer to literature review that has been proposed recently by two Chinese colleagues, because China is also, the academia in China is also contributing a lot to that debate. And here we see synthetic way to represent by the word cloud, which are the main subjects that have been studied in the literature. The first is trade leakage, and it is interesting because in the previous talk, in the example, the trade leakage was kind of missing point. On the other way around, so this is really at the heart, together with competitiveness, of the research that has been made in economics. So competitiveness and trade leakage are the two main points. But what the literature says, so beside the fact of talking about which are the effects, so it's something that we can see in the next slide. So as the baseline is the idea that we have to do this carbon border adjustment without losing competitiveness. And the problem is that where we can lose competitiveness, or the other way around, where we can gain competitiveness, well, it depends on the compliance effect of CBAM. And then there is a bunch of the literature that says we have this mostly policy oriented, that says we have a risk of carbon leakage. What it is? Carbon leakage is like when you don't want to pay the tax and you go in the fiscal heaven. Well, it is more or less the same effect, except that you just delocalize the activities that are subject to regulation, to a carbon regulation. And this has been really also the argument from the lobbies of the industry that is going to lose, as we have seen, the benefit of free allocation. And they say, well, if you give us now a price, we are going to delocalize. If we go into the past, and because this was already an issue when introducing the EU ETS, there is no economic evidence. And when I say no economic evidence, is from the point of view of the causality that econometric model can show. We don't see these links between having a regulation and carbon pricing and the delocalization. Of course, it is closely related to this idea of competitiveness, because the main point is that there is an input or several inputs whose costs are going to increase due to this new regulation on carbon, and therefore this would be enough to delocalize. The point is that we have many reasons to delocalize that are perhaps more long-term and more related also to the labor market than to the carbon market. On this point, it's also crucial to understand how this additional cost is going to be transferred to the final consumer. This is the issue that in the literature has been studied under the name of pass-through. If it is a cost that hinges on the different sectors, then the way in which firms are going to recover this cost is to embed it into the final price. But this logic really depends on the sector and the goods that we consider, and mainly all the debate that I'm going to unveil a little bit on elasticities, that is, which is the reaction of the final consumer to the increase in the price, and also which is the market structure of the goods that we are considering. Because something that has not been said so far is that the way in which those sectors work is also depends on the strategies of firms. And these strategies of firms, of course, also depend on the way in which they have market power. Most of the sectors to which this carbon border adjustment are going to be applied aren't perfectly competitive, which means that in any case, the pass-through won't be complete. So the cost won't be transferred 100% to the final consumer. But still, how we reconcile this policy-oriented debate with what has been assessed is something that we have to clarify. So now looking to some other results that we can have from the literature. Shifting to the, yes. The issue of competitiveness, sure, there will be perhaps a disadvantage comparing the EU firms to the non-EU markets. But there is also something that is perhaps mitigating this effect. One is the long-term impact, the fact that also the recycling of the revenues from the CBAM will transform into subsidies to low carbon technologies. And the other good news is that at the end of the day, what we want to have with this CBAM is that the other countries should at some point be convinced that the easiest way not to make all this complex calculation that we have seen so far is to have a carbon price. I mean, I'm going a little bit, into the paradox, but if we have cousins and friends and peers that are going to implement EU kind of regulation in terms of carbon pricing, then what will be, the main point will be the difference between the carbon prices, which is going to be the main determinant of the competitiveness effect. Another point that is going to be very important, and again, I refer to the previous explanation to really understand the complexity of the problem. Something that is part of, for instance, of my own research is this idea of reshuffling. So what it is targeted with the CBAM is upstream. So what we do in some sectors, but all these firms that are subject to this regulation are multinational firms, or at least they are multi-located, even within the same country. So there may be also a strategy which is to not to take all the problem upstream because the upstream is regulated, but to displace the carbon leakage problem more downstream. So perhaps the carbon leakage is going to be manifested along the value chain much more than in the NACE code of the upstream sector that is subject to this regulation. So this may be a form or a new modern way of having the leakage that is redistribution among different regions. Just before giving to some questions, that is which are the countries that will be disadvantaged or not by, and taking into account in particular this second layer effect, let me summarize a few numbers on what has been, I think, in a quite robust way achieved by the literature in terms of evaluation of leakage and competitiveness problem. So it has been estimated that I'm reading the numbers because there are many. So if we consider the EU ETS price at 100 euros per ton, there could be, and this is something, well, as I told you, it's a projection, an increase of the competitiveness globally at the European level of 0.38%, whereas the global loss of competitiveness in the rest of the world is very tiny, is to be estimated to 1%. So, and this depends on many effects. One, on the characteristics that, something that is really into the detail of the design, or as we have seen so far. And the other part is how to calculate the economic efficiency of the CBAM. And here we have the direct effect, that is really a question of how prices are going to compare within the EU and outside the EU for a given good. And here, the main point that has been raised by the economic literature is to understand the trade elasticities, that is how we can substitute a country with another in the supply chain. And the other point is also the strategies of the firms, that is how they are going to create an indirect effect, that is by changing their business model somehow. So now going into something that is more on the macroeconomic side. The issue is who is going to be, even if it is 1%, we don't know yet, because I mean, it is something that we, with this data that are being collected, I think that the models can also be fed with more realistic assumptions. So here, the question is, which are the countries that are going to suffer from the CBAM? That is, who is going to reduce substantially the export into the in Europe. And here I present a result that is from the AFD, so Agence Française de Développement, who is really concerned about this question. And we see the ranking of the effects within different trading countries, trading partners, and according also to different products, aluminum, cement, electricity, fertilizer, and iron and steel, that have also been, taken as an example before. Globally, we see that in terms of ranking of the countries, and this result is robust also to many other studies that I've seen, Russia, China, and Turkey are the most affected one in terms of value, but not in percentage. So, and here it comes with the example of Mozambique that I'm going to explain a little bit. So going to the next slide, which is the problem with this country. Mozambique sends 97% of the aluminium export to the EU. So he produces a lot of primary, and Matthieu was explaining this problem of recycled aluminium. And this is going to be tackled as it is in the direct emissions scope. Nevertheless, it uses hydropower. So if we take into account indirect emissions, we have an advantage. So depending on where we set the limit, scope 1 or scope 2, we'll have that the exposure of Mozambique is going to drastically change. And this was just an example just to see how we can vary the exposure, both in terms of value, but also in terms of percentage of exposure. And of course, this is a major problem for, in particular, for the global south, that also doesn't have this a similar complexity in terms of carbon pricing. If I have also to rank something that is not in the previous slide, but to understand a little bit how it is then developed in terms of sectors, the sectors that are, according to the literature, are more exposed are in terms of direct impacts are chemical and non-metallic goods. In this kind of sectors, Russia is still the country that loses more, but also for the non-metallic sector, also China and Turkey. Who gains is within now the European countries, Germany, Italy, and France. Here we see further this problem of different exposure that is really going to be very sensitive on the scope that also Matthieu was explaining. And this is also going to call for something that is maybe in the air but not yet established, that is the usage of export rebates. Perhaps in a transitive phase, in order to somehow give a little bit of time to the trading partners of the EU to readjust. But still, here what we see is that the percentage, the relative exposure can be important, but overall, the average exposure is more or less between 10 and 5%. So going to the next slide. Some readings that I just suggested to go into, on one side the design and the other side the developing countries, and I'm just leaving you because I mean that we are already at the with the clock that is at the end, but I will just add something, a couple of numbers. The issue of the reshuffling, whether it is the local or the value chain considered or at least simulated. This is a point that we make in the research that is summarized by the first paper. Is that without reshuffling, the overall emissions that we tackle is 83 million tons. With reshuffling, we are going to consider something that is 5 to 10 times more. So the issue at stake is huge, whether we consider this problem of the value chain and whether also we include or not export rebates. And that's it. So in the meantime, this is also research that we do at the Climate Economic Chair, and I hope there will be also more bridges between our institutions that I'm bridging along. So I think that this is also something that we can really benefit from, the detailed calculations and the assessment that is done on a very nice way, and something that we can plug into more in economic research as well.
Quentin, your mic is on mute.
Yeah, thank you very much. Thank you, Anna, so much for all these precious insights. For our viewers, we will now you will find on the chat a little link for a form to better know your interest on the matter. We will propose you different options on subjects we would like to expand on in the next months. So please just if you want, if you can, click and tell us what you think about all of this. And if you want more of this kind of little webinars or trainings or events, even I would say, please feel free to tell us. Now, I think we have just some minutes to answer the questions. We have little questions. Maybe Houssem, do you want to tackle the question, sorry, of Aurélien Denis? I think we can put it on the screen. Yes, about the free allowances, maybe in the calculation.
Yes, very good question. And just to keep in mind something is that the European Commission will publish an implementing act with all the details about how to calculate the number of certificate of CBAM certificate to be surrendered by the declarant. But just in the draft documents of the consulting firms that are working with the European Commission, the equation is to consider the embedded emissions of the goods in the first part of the equation. So you have the specific embedded emission that are multiplied by the mass of imported goods. After that, we have a minus of benchmark product of the same product. Yes, so we have the benchmark product of the UTS of the same imported product that will be multiplied by the mass of imported product and by a percentage of free allowance ratio. So phase out. So if you are in 2026, it is 2.5% here of free allowances that are phased out. So it will be multiplied here by this percentage, and we have here difference between embedded emission minus benchmark product multiplied by mass by this phase out ratio. So we will have the first part of the equation, and the second part is the carbon paid in the country of origin. So it will depend on these parameters. This is the draft version of the implementing act, but it is subject to discussion. But just to keep in mind, according to this vision, free allowances are taken into account through this benchmark product.
Thank you very much, Houssem. And I have another question for you. You mentioned like the transitional registry of the CBAM at the EU Commission. You mentioned like some kind of authority in the member states. Is everything already in place, or are we still like wondering how we will manage the well, normally already reported numbers for the first phase?
Yes, I think there were some issues with the submission of report in the due date. So the European Commission made an extension of delay for these importers because there is technical problems with the registry. I don't have an extensive idea about other European countries, but we are in talks with the French Ministry of Environment about the training on CBAM. And according to our discussion, there is some problem also with the French registry because there is some customs identification number that must be inputted to be able to access to the registry, and there is some issues about such access to the registry. But I think if there is an extension of delay, I think there are many issues about how to access the registry for the first report, I think, submission.
Yeah, thank you, Houssem. So just stay calm, everybody. Everything will work definitely at some point, but for now it's a bit complicated. We have a question I think it's for Matthieu, from Niels. Or indirect emission from heat supply, not part of the CBAM. Matthieu, you talked about like the different role of heat in comparison from Bilan Carbon to CBAM. So can you please just get back on that, please?
Sure. So what Niels called indirect emission from heat supply part of CBAM. So first, we have to identify if this heat supply on consumption is related to production process or not. If it's to heat your offices, it's out of scope. It has to be related to process. And then what we call indirect emissions in the sense of Bilan Carbon will fall under direct scope of CBAM because the heat consumption in the sense of CBAM is part of the direct scope, even if not produced on site. So it will be taken into account in the CBAM scope for sure, but in the direct scope in the sense of CBAM, even if falling under ISO 1464 scope 2 in our previous common language.
Thank you, Matthieu. I have another question. Like you mentioned, like the fact that for direct emissions, measurement was recommended. So we can expect that every producer around the globe will take measures of their emissions. Will there be any kind of control about those measures? Because we can control the emission factor database, for example. We can give some like the SEE values, like means but the measurements we have to trust. So will there be a kind of control? How do you think will it work?
So I'm not sure, Quentin, if the question is for me or for Hussein.
I mean, if you have an idea, Matthieu, I'm glad to hear it, but Houssem can participate.
For now, it's still not clear.
Okay.
I understand that for now, as a CBAM declaration, it's only declaration without verification for this transitional period. Afterward, it will be subject to verification, and I understand that so far it's expected that the EU ATS verificators will be eligible as CBAM verificators in the first step. And then we'll have some local entities, perhaps some national entities that will be able to train and attribute the certification of local verificators. That will be at this stage. For now, it's important to remember that what's compulsory is to report embedded emissions, which are not subject to any financial adjustment. The financial stake is just to avoid a sanction in case of non-reporting. So what's important for now is to report a figure. So in 1 year and a half, we'll have some first financial adjustments that will come. And at this time, we'll have some verificators that will be in place. And so far, we don't know that much what will be permitted and the verifications that will be necessary on measurement tools. Yeah.
Thank you.
If I can complement, I've also heard that this kind of verification will be part of bilateral agreements, depending on how the follow-up of the CBAM will be made, which is also going to it's something that may change, especially because perhaps it's something that we haven't stressed so far, is that there is an overarching problem here, is that this part of the CBAM will also be discussed in the light of the Paris Agreement. So, and this is also an important way for each country to reassess not only the obligation to report, but also the obligation to evaluate and to understand which is the audit that can be made on the figures, which is new, because everything that concerns the Paris Agreement is about the allocation and not the prices. So it's clearly something that has to be managed either bilaterally or within the scope of the COPs.
Yes, of course. And I think, like,
if I can add something, Quentin? Yeah, thank you very much. Just about the measurement, if you are talking about measurement-based approach, based on continuous emission measurement system, if it is the question, here we are about talking about measurement of GHG concentration and volumetric flow of gas stream. And this method is the second method allowed by the European Commission for CBAM, starting from 1st January 2025, and starting from now, but it is obligatory starting from 1st January 2025. This second type of monitoring approach, it is mandatory for nitrous oxide emissions monitoring. It is not obligatory for all other sectors, but it can be used for monitoring CO2 emission if it gives more accurate results than the calculation-based approach, which are based on activity multiplied by calculation factors or mass balance method. Just to give this explanation.
So there are already some kind of, I would say, ways to ensure the quality of the data. But we will see. We will see if it's if it gets where it needs to go. I would say, like, maybe a last question. It's for you, Anna, because I think it's more like in a more philosophical way, I would say. It's so I don't have the name of the person who has this, but they say, how far do you trust that, unlike ETS system, CBAM will lead to reducing absolute GHG emissions? In short, can giving an economical value to global warming help tackling it? So it's a very, very general question. I don't know, Anna, if you have some elements. Do you trust that CBAM will be effective in terms of reducing emissions globally, or do you think it's just another step, but we still need to improve in the next decade?
Well, it is true that at some point it is natural to say that we are complexifying our lives and to do what? First, I mean, the EU ETS has been effective to reduce the emissions, in particular, of the electricity sector, which is 60% of, if not more, of the EU ETS. I mean, to reach this objective, it is true that the ETS has been reformed, and it will also continue to be reformed to go more straight to the net zero economy, and also to understand more how it can put pressure through the CBAM to the other partners. How this is going to be integrated in the overall, because in Europe we are very, our measures are quite stringent, but nevertheless it is true that we represent only 5% of the global greenhouse gases emissions. Maybe a little bit more if we include aviation. I mean, in terms of what we regulate. Well, it's we'll see, but I can give you the first answer. That is, now that we have the CBAM, Turkey is discussing to introduce a carbon tax. And so we see that clearly with the result that we have shown, it seems that they anticipate a little bit that they will be impacted. And this is the kind of effect that I think are very positive. At least if we have spillovers in terms of regulation, this is the first step to reduce greenhouse gases emissions.
Okay, thank you very much. I think we will end now. I see other question. Maybe if you want, we can give some written answer. But I think we have to conclude. Thank you very much, Houssem, Anna, Matthieu, for all those very, very interesting insight on the CBAM and different ways of approaching the matter. So ABC and its partners would like to, of course, provide to our viewers in the near future, like more webinars, more training, maybe new tools. We have seen that Bilan Carbon can be used, should be used. We will see in the future. And I would say generally the means to share the best practices on the CBAM. So feel free to connect with us. Feel free to connect with especially our international low carbon transition community in LinkedIn for more information about all of this and to just discuss about what we can do all together. Thank you again, and I wish you a pleasant day. Bye-bye.
Goodbye. Thank you very much.
Goodbye. Thank you. Have a nice day.
Bye. Thank you, everyone.
See you.